So you've got different solar panels, different wattage, maybe even different specs. And now you're thinking, can I actually connect them together without messing things up? In this video, I'll break it down in a simple way, so you can decide the best wiring method for your setup. Let's quickly understand the two basic ways to connect solar panels: series and parallel. First, series connection. In a series setup, the voltage adds up, while the current stays the same. For example, imagine you have two panels, each producing 20 volts and 5 amps. If you connect them in series, you'll get 40 volts and 5 amps. So basically, voltage doubles, but current does not change. Now let's look at parallel connection. Here, it's the opposite. The current adds up, while the voltage stays the same. Using the same panels, 20 volts and 5 amps each, when connected in parallel, the result becomes 20 volts and 10 amps. So in this case, current doubles, but voltage stays constant. Now here's where things start getting interesting. When your panels are not identical, meaning different wattage, voltage, or current, you can't just connect them randomly. You need to look at their specifications first, because that decides whether series or parallel will work better. Now let's talk about mismatched solar panels. This is where most people get confused. The key idea is simple. If your panels have similar current but different voltage, go with series. If your panels have similar voltage but different current, go with parallel. Let's break this down with a real example. Imagine you have two panels. One is 100 watts. The other is 200 watts. Together, that gives you a total of 300 watts. Now, in this case, both panels have different voltage ratings, but their current is similar. So the better option is to connect them in series. When you do that, voltage adds up 20 volts plus 40 volts equals 60 volts. Current stays the same 5 amps. So your final output becomes 60 volts and 5 amps equals 300 watts. That means you're still getting the full combined power. Now let's flip the situation. Same panels, 100 watts and 200 watts, total still 300 watts, but this time both panels have the same voltage, and the second panel has higher current. In this case, you should use a parallel connection. Here's what happens. Voltage stays the same, 20 volts. Current adds up 5 amps plus 10 amps equals 15 amps. So the final output becomes 20 volts and 15 amps equals 300 watts. Quick tip: when you connect panels in parallel, current increases. And higher current means you may need thicker wires to avoid losses and heating. Now what if your panels are completely different? Different voltage and different current? That's where things get even more interesting. Now let's take a more realistic case. You have 3 different solar panels. Panel 1, 20 volts, 5 amps equals 100 watts. Panel 2, 22 volts, 4 amps equals 88 watts. Panel 3, 18 volts, 6 amps equals 108 watts. Now let's compare both wiring options. First, series connection. In series, voltages add up 20 plus 22 plus 18 equals 60 volts. Current follows the lowest panel, 4 amps. So total power becomes 60 volts times 4 amps equals 240 watts. Now, let's check parallel connection. In parallel, current adds up 5 plus 4 plus 6 equals 15 amps. Voltage follows the lowest panel, 18 volts. So total power becomes 18 volts times 15 amps equals 270 watts. As you can see, in this case, parallel gives better output. But there's something important you should always remember. If the difference between panels is too large, you will start losing efficiency. In those situations, it's often better to use separate charge controllers instead of forcing everything into one system. Now, Let's look at a hybrid connection. Say you have two 50-watt panels, one larger panel. Total system equals 200 watts. First, connect the two smaller panels in series. That gives you 20 volts and 5 amps. Now this matches the bigger panel's rating. So now you can connect both sides in parallel. Final output becomes 20 volts and 10 amps equals 200 watts. This method helps you balance mismatched panels and reduce losses. But again, if things don't match closely, splitting them into different charge controllers is usually the smarter move. If this helped you understand mismatched solar panels, make sure to like the video and subscribe to Battery Hacker for more practical solar tips. And if you want, I can also show you how to safely use multiple charge controllers in one system.